Okay, so here we have our rules. Um, there's a lot of them. These are tricky problems. They're the first hard thing that we've done as far as math is concerned in this class. There was the bottom, by the way. If they were not whole numbers, multiply all by whatever number. Is whatever one word? Who cares? Whatever number you need to make them all whole numbers. We don't have any of those today, so if you end up with one of those, then you have a problem. All right, all of them today will have oxygen. So they are the harder ones that take multiple steps. All right, and if we have time, there's a much quicker way to do this, but you have to understand like all the parts in order for the faster way to make sense. Okay, and there's more than one way to do them. You don't have to do it my way, but this is just the like less perilous way to go about doing this. All right, so here we go. Here's our first example. Oops, we already did that one yesterday. Here's our first one. All right, this box you don't have to have. I used it. Look, I think all of them might be on the homework. So if you haven't done your homework yet, then this will be helpful. If you have, then this will seem like a piece of cake. This box, I made it just to keep track of my moles of everything. Okay? Because ultimately, all these steps are really, we're just trying to find the moles so we can divide by the smallest value and find our molar ratios. Who's with me? Two of you? Okay, good. All right, give this a shot as quick as you can, which is like asking a Walmart truck to drive faster on the freeway. It just doesn't happen. Let's pick this problem back up. I know that they take time. I don't expect you to be perfect at it yet, but hopefully we're getting closer on our fails. Okay? I tell my high jumpers all the time, all we want to do is fail better every single time. Here we go. So the first step I told you to do in these, whatever, find the moles of carbon from carbon dioxide. So here we go. I'm going to take my 0.2829 grams CO2. I'm going to make my pen thinner. And this is 44. I would, if I were you, put point something something. I'm going to round it because I'm lazy. CO2 for every 1 mole. CO2 for every 1 mole CO2, I have 1 mole of C. And I'm going to pause for right now and put that answer down. What is this answer right here? 0.006 what? Okay. I'm going to put that right here. Just for me to keep track of where my crap is at. Because I'm going to write a lot of stuff in this paper, right? All right, then I'm going to do the same process for water. 0.1159, and that's grams of H2O. I have 18 grams of H2O for every 1 mole H2O. For every 1 mole H2O, I have 2 H's from the formula. All right, and then I'm going to put this number down, and what did it turn out to be? 0.0 what? More than one person agree to that value? Okay, I'm going to put that right here. Okay, 128, 129. We can't tell me 128, 129, 127. Oh, okay, okay. All right. Hold on, I'm going to do this just for clarity. What this box is, it's my moles. That makes the table make more sense, sorry. So the last thing I need to find are my moles of O, right? But to find the moles of O takes a lot more work. So we have to come back. I have to take my moles of C and convert them to grams. So to do that, I multiply it by 12. And to do this, I multiply it by 1. I don't mind doing that one. What's this times 12? Then what do I do to those two numbers? I have to add them. So I'm going to take my grams of C, 0.0768 grams of carbon. I'm going to add it to my grams of hydrogen, 0.0128 grams of H. And I get a number. Did anyone write that number down? 0.09 what? 0.0896. All right. Now, this is the mass of C and H. It's not the mass of O, right? So now I take my original mass, which is 0.1005, and I subtract this total mass, 0.0896, and I get a value of 0.01 something, 09, and that's my grams of oxygen. So now, what do I do to my grams of oxygen? Do I want grams? No, I want moles. So to do that, I have a quick 16 grams for every 1 mole. That gets rid of grams. Now I have a number of 0.00 something. Or is there another one? 0.000 what? We okay with those values?
Well, wouldn't you only need one significant figure since the least significant figure is a single plus one?
I have
Like
4,
1 mole of carbon,
4, 4. You don't, for the 1 mole, you ignore that. That's an absolute number. So really, you should have 4 sig figs in every single calculation. All right, so it's not going to matter a ton. Okay, now that I have these 3 values, I'm very closer to my answer. What do we do once we have all 3 of the moles? I'm going to get rid of this. That's confusing for a second. I divide them all by the smallest answer. So this is the smallest answer, 0.0068. So O is going to be a 1, correct? This is 0.0068. I forgot 10, whatever. That is a 20. 0.00068. I'm not rounding to the 4 sig fig. I'm writing my value with 4 sig figs, which are extremely different. 0.0007 is only one significant figure. So 0.0068 is 2. So technically speaking, we should have a number and a number, which will help us get a lot closer probably to what we really, really would have. When you do this, if you didn't round it all, it should be pretty close to a 10. So our value would be, or our answer, C10, H20, O. Who had that answer? Raise your hands. 1, 2, 3. Holla. Well, if you're super close, then you're doing super okay. We're going to do another one, and we'll see how it goes. Yeah. Well, look.
I did everything right, but then it ended up in a
on the top I got page 3 zeros and 2133. On the top one you put 3 zeros.
But I did everything right, and then it ended up in the decimal.
On the bottom you put 1.
Okay, all I would tell you is I know this is C10H20O because I've done it before. Um,
Then there should
so
be 3 zeros on this
on the O's there is, not the C, that's .0064, but the bottom is. So look, what our problem is I'm lazy. C, when we find CO2, you should use 12.011. For O, you should use 15.9994. Like you should maintain every value forever, and the more accurate you are, the closer you'll get to a whole number. So while we're off is because we're being a little bit lazy.
Is it just when the decimal can be turned over whenever you do?
Right. Yes.
So if you get like, 1.00 whatever, you could just use one.
Then you're rocking, yeah. If you have even 1.08, 1.1 even, I'd say you're probably right. If you get 1.33, then you're probably obviously needing to multiply it by 3. So I'm a little bit worried. Your numbers were on. Were they 3, 3, and 6, 6? So I don't know where we went a little bit astray. This next one doesn't have as big of numbers. Let's see if we can do this one. Is what? Is what? That divided by that is 1.88. Did you put 3 zeros in your decimal? In your denominator, I mean? All right, this one doesn't have as big of numbers, so it should be a little bit easier. This underlined part, if you don't know how to do that yet, don't worry. That part is not hard. So if you don't know how to do it, relax, we'll fix that. So give this a good shot. Okay. These take a lot of time. There is a faster way. The instructions are right down here on the faster way. Don't. Oh, I gotta. Here we go. Whoops. Then. I don't know what that was, but I'm happy about it. Anytime his life isn't perfect makes me happy. Probably. All right, so here we go. 2.257 grams of CO2. And while I'm at it, 0.0350 grams of H2O. We all right with that? 2 straight lines, maybe? Hey, that's pretty good for me. 44 grams CO2. You should not round, but I do to save time and space. 1 mole CO2. 1 mole CO2 for every 1 mole of C. And then I'm going to put my mole of C right here. What did this answer end up being? 0.00584. All right, then my H, I have 18, I have 1. I know I'm being lazy. I have 1 and I have 2. Are you with me? And what did that end up being? 388. Forever. Sounds good to me. That's ugly, but it was 0.00388. All right, now, unfortunately, this has oxygen in it. So what I'm going to do, because I am Tom Davidson and this is how I roll, I'm going to put this part into a picket fence. For every 1 mole of C, I have 12 grams. That's the same thing, just multiplying it by its mass. And what do you get here then? What was the grams of C? Everyone agree with Rass's number? Uh-oh. What? 0700? Okay, I'm okay with that. That's 5 ten-thousandths difference. We'll be okay on that one, I think. And you're like, what? Sometimes you tell me to round, sometimes you don't. Well, I'm sorry. All right? Not really. Okay, this one I can do in my head. Oops, yeah, I can. .00388. I'm going to say 9. Was it just 8 repeating forever? Okay, whatever. It's not going to matter that much. That's my grams of H, I mean. What do you do with those two numbers? You add them. All right, when you add them, you get some value. What does that answer? .0735. Good enough. All right. Now, a lot of people right now, they do all this right, but then they use that number incorrectly. They divide that by 16. But before you do that, subtract from your initial, right? So your initial is 0.105. And that equals 0.00. Is that right? 0.03. My fault. Well, someone's telling me 0.03 and someone's telling me 0.001. 001 what? Okay, that sounds good. I know John had the right answer, so we're just going to take that number. All right, and that is grams of O, so we're close. What do we need to do to this number? Divide it by 16 because that's the grams of oxygen. That's the molar mass, right? And then I'm going to write that number up here. What was that number? Point. When you divided your answer by 16. Someone's got to talk louder. You all did it. Tell me this number.
I got a different one since they got a different answer for that. Yeah, we all sort of remembered differently. So we all have different answers for the same. I divided it by 16.00197. That's what I got.
Okay, so this right here was the answer. Okay. All right, so this was the answer after it was divided by 16. Okay, so I'll just throw 16 right here and we'll call that good. Are you okay with that? All right, my fault / mostly your fault. 0.00197. Oops, I already had the point. Okay, now I have, oh my heavens, this is annoying. I have 3 values. Which one's the smallest one? They asked me last hour, is O always the smallest? No is the problem. The problem with chemistry is as soon as you use the word always, you're almost always wrong. It's the science of exceptions, as one of the Hardy Boys a long time ago called it. All right, when we do this math, we should get a 1 for the O. This was a 2, right? And this was a 3. All right, that was not as terrible as the last one. C, yeah, there you go. C3H2O. Now, this process is finding the empirical formula, right? This, though, says given a molecular weight, so we want the molecular formula, of approximately 108, what is the molecular formula? All right, so finally there's a part of this that actually is simple. You add these parts up. So you have 3 C's, 2 H's, 1 O, and you get 54 grams as its molar mass. But the instructions tell you it should be 108. So how does a 54 become a 108? You multiply it by 2. So everything gets doubled. C6H4O2. Woo. Who had that? Let the record show that there are 1, 2, 3, 4, 5, 6, 7, 8 hands raised. Who had at least the first part? Raise your hands. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so half the class is getting it. That's actually not acceptable, right? If you're the half that's not getting it, you're like, okay, I hate everything about this class as of right now. Well, you already did last week too, so it's nothing new. All right, now I only allow you to use this if you get it 100%. Okay, follow my process here. These numbers, well, let me scan up. I should bring this with me. These numbers, if you looked at the last two problems that we did, you would notice that this part was the same both times. So if you're always going to do the same math to this first number, why waste your time writing it all down? Now, this could blow up everything you just understand, so be careful here. All of this math right here ends up to be 0.2727. That gets you to grams of carbon. And all of this math right here is 0.1111. That gets you to grams of H. Now, H is nice because the moles and the grams are the same, right? But carbon, you got to be careful. If you do this trick, you're going straight to grams. So you would then also need eventually to divide that by 12, right? Okay, but you can do this in your calculator in about 10 seconds per line. 0.257 times 0.2727, and you have this number instead of writing that all out. You can do it with hydrogen. That number times 0.111, and you get grams. All right? Right. Right. So this quicker way, it's pretty much the same after that. To get your grams of C, you that, grams of H, that, add both and subtract from original mass, and you're off to the same exact process. You with me? So the quicker way is to ignore the two picket fences at the start and just remember those two constants. And I went to 4 decimal places because most of the time that will keep you clean enough. If I just did 0.3, you'd be dead. All right? So none of these are that different. They're pretty much the same. Okay, we'll pick it up here. Please, if you haven't done the homework, now you should have enough knowledge to complete it. And then we'll do one of these tomorrow and then move on to something different.